This example is from MGF 1107, Explorations in Math. And in this example, we have what we call a traveling salesman problem, where we have an individual who wants to visit many other cities and then return to his own city and form a Hamilton circuit. But we want to do that such that the cost, in this case, the cost happens to be for one-way flights between the cities, is a minimum. So we want to minimize the total cost. Now to do that, we're going to have to first construct a complete graph, which means it will have several vertices, and every two vertices will have an edge or a flight connecting them, and each edge will be associated with a cost of the flight. And then we're going to want to find all the different routes that, in this case, Mark Jacob could take to go from Tulsa, Oklahoma, and visit all these cities that he may go to graduate school in, and then at the end return back to Tulsa, Oklahoma. So we're going to have to figure out how many Hamilton circuits exist, and then figure out the cost of each Hamilton circuit, so then we could find the lowest cost. There's also another method called the nearest neighbor method, but that only finds us an approximate lowest cost. It might not find us the optimal solution or the lowest possible solution. So I'm going to start this problem off by constructing a graph. And you notice we have Mark Jacob. He lives in Tulsa, so that's one city, Tulsa, and he's going to attend graduate school for PhD in chemistry. And he wants to visit the chemistry departments at Berkeley, which is in California, Madison, which is Wisconsin, and in Chicago. So we have 4 cities, 1 which he lives in and 3 that he is visiting. So we're going to have 4 vertices on the graph: Tulsa, Berkeley, Madison, Chicago. And then we're going to have an edge connecting every pair of vertices. And then we have different costs to fly from one city to the other cities. And at the end, we want to find the minimum cost. So what I'm going to try to do first is magically have a graph appear. Let's see if this works. Ta-da! There is what we call a complete graph. It's a complete graph. It has 4 vertices: Tulsa, Berkeley, Madison, and Chicago. Those are the vertices in the corner, and then there's an edge representing the flight, or the cost of the flight between the 2 cities. So here's what's called a complete graph. That's usually step 1, is to construct a complete graph. And now I'm going to go and label it with the cost, or what we call the weight of the edges. So between Tulsa and Berkeley, it's 604. So let's see if I can just write right on this. So that weight is 604 from Tulsa to Berkeley. From Tulsa to Madison, this long one going across here, is 510. And those are in dollars. From Tulsa to Chicago is 490. From Berkeley to Madison is very expensive. I guess that's from California to Wisconsin, 821. From Berkeley to Chicago, 699. You notice it doesn't matter where you put the vertices in your visual graph. That's not important, and it's not important that the actual length of the edge determines the weight of the edge either. So Chicago to Madison, that's from Illinois to Wisconsin, that's pretty close. Chicago to Madison is 98. And we're assuming it doesn't matter which way they travel between Chicago and Madison, it still costs $98. So I think we have all edges. I think there are 6 edges there, all 6 edges with a weight. So now what we want to do is, to find the minimum cost, you have to find all Hamilton circuits from Tulsa through all the other cities exactly one time back to Tulsa. So I'm going to list that out over here using the letters, the first letter of each city name. Again, he lives in Tulsa, so it has to start in Tulsa. So I'll just write Tulsa to Berkeley to Madison to Chicago to Tulsa. That's one Hamilton circuit. Remember, it's not an Euler circuit. We do not want to use all the edges or all the flights. We just want to visit all the vertices. So that means it's a Hamilton circuit. Or we could go Tulsa, that's where he starts, to Berkeley, to Chicago, to Madison, back to Tulsa. Or he could go from Tulsa to Chicago, to Madison, to Berkeley, back to Tulsa. Or from Tulsa to Chicago, to Berkeley, to Madison, to Tulsa. That one might be expensive because Tulsa to Illinois, to California, back to Wisconsin, out to Tulsa, that's probably not going to be the optimal one. Another one is Tulsa, then next to Madison, to Berkeley, to Chicago, to Tulsa. And you could draw these on your graph if you want to. And then Tulsa to Madison, to Chicago, to Berkeley, to Tulsa. And there is a formula in this section that said the number of in a complete graph, the number of Hamilton circuits will be n minus 1 factorial, where n is the number of cities, or in this case cities, but vertices in general. So that'd be there are 4 vertices minus 1 factorial. 4 minus 1 is 3, so 3 factorial. 3 factorial means 3 times 2 times 1, which means we should have 6 Hamilton circuits, and we have all 6 of them listed over there on the right-hand side. Now we have to calculate the cost of each one, so we can pick the one that's the optimal solution. So to do that, we're just going to follow the circuit and add up the values. So this is just a little bit of calculation. I'll do one of them and then I'll magically have the other ones appear. So from Tulsa to Berkeley is 604, plus from Berkeley to Madison is 821, because that's cross country, plus from Madison to Chicago, that's pretty close, plus 98, plus Chicago to Tulsa is 490. So the cost of that trip, just to visit those grad schools, not including hotel or food, is $2,013. Now I'm going to follow each of the other Hamilton circuits around and add their flights up for their cost and see what we get for them. So what I did is I listed the cost of each of the Hamilton circuits, each of the 6 Hamilton circuits, and determined that there was one that had an optimal cost, or the lowest cost, and there's actually 2 that tie, and they're just the reverse circuits. So the circuit from Tulsa to Berkeley to Chicago to Madison back to Tulsa for $1,911, or the reverse of that, Tulsa to Madison to Chicago to Berkeley to Tulsa, that would be the optimal solution. That would be the lowest cost of any of the Hamilton circuits. So let's draw that on our graph. So again, that's Tulsa to Berkeley, Berkeley from California to Chicago. Once you're in Chicago, go up to Wisconsin to go to Madison, and then you got to get back home. Mark Jacob had to get back home, so he only had one choice left, and that was to go to Tulsa, and that would be the optimal solution, that or in the reverse order. So to answer the question, the minimum cost for Mark to visit all those schools and return to Tulsa would be $1,911, which would be answer D there. There's no way that you could do it for $1,216 no matter which flights that you take.